Hey everybody, Happy New Year. Hope everybody's doing well. Been a while since I put up a video. Today we're going to do a little bit of a odds and sods video. I have a little bit of a cold here, but aside from that, everything's going well. New Year's Eve was really good. I had a gig at one of the larger venues here in Jacksonville, and it was fun. And there was a theme of, obviously the Roaring '20s. And here's a picture of what I looked like that day. We all had to dress up a little bit for it. So here's a picture. And I'll put it up on the screen now. Okay, so what are we looking at here? So if you remember, a while back, I built a Fender 59 Bassman amp, and this is the chassis that you see right here that I built. And when I built it, I tested it and everything, and it was great. It worked good, but I never really gave it a workout. I never really played through it and used it because it was one of the things that I wanted to do, never got around to it. So for New Year's Eve, I decided for this gig that I had, I was going to bring this amp and I was going to play it. And lo and behold, when I took it out and plugged it in at low volume, it was working perfectly. As soon as I put the volume up to like 4, I got this big shrill sound, and I'm like, oh man, something's wrong with this thing. So what we're going to do today is we're going to go through it and see if we can figure out what's going on. So just to set up the scene here, what you see right here is an 8 ohm dummy load, and I have the dummy load going right here to these 2 gator wires, so that's going to simulate a speaker, so that's connected. And I also have the this box connected to my oscilloscope right here, and you can see that. And I have a signal generator connected to the normal jack, and it's currently running about 800 hertz and about 100 millivolts, I think. So let's turn this thing on, and we're gonna. First thing I want to show you is the symptom. So let's turn it on. We're gonna let the tubes warm up, and you'll see exactly what I'm talking about. It's really, really strange. So the amp is on. Got it connected to a dummy load, 8 ohm. Here's our scope. Let's put our volume up, and our volume is at about 4, and you'll see it's pretty solid. Watch what happens when I go a little bit higher. Alright, that's on 6. Now watch what happens when I go over 6. So we'll stop that. So I'm going to leave my volume on 4, and you'll see there's already, it starts to get bad around there. When I turn up my presence knob to 4, my middle to 4, my bass to 4, my treble to 4, you'll see it changes the signal significantly, and that just gets crappy. And the only way I can get it back down to normal is to bring the volume back down to 3. So not only do I have a problem with cranking up the volume, the tone stack also contributes. So I'm going to turn the volume all the way down to nothing. I'm going to put treble, bass, middle, and presence all the way up. Let's see what happens. See that? We got some major squeal going on here. So I think I think we probably have some parasitic oscillation. Maybe that's what it is. I'm not really sure. I've taken a look at the wiring and the chassis. Everything is where it should be. I've checked all the solder joints. I've checked all the connections. As far as I know, everything is good. All right, so let's talk about our symptom here. So our symptom is that when we raise the volume up, we break up and we have some what I think is parasitic feedback, but we'll have to prove that. But if you look at the schematic that I'm showing you here, you actually see the signal path. So here's the normal channel coming in. All right, so this is where I had our signal generator connected. And it comes in and goes through 1/2 of the 12AY7 right here, which is all fine. I don't have any problem with that tube. And it then comes over here to the 12AX7, which is valve 2, and it's the preamp. And there's a cathode resistor, and let's see, what else do we have here? A load resistor. And then we have our volume pot, which is right here, which connects directly to one side of the 12AX7. And we need to check that. And then we go right to the tone stack. So if I had to guess where the problem is in this amp, it's going to be somewhere right here in this section. So we've got 1/2 of the 12AX7 here, and we got another 12AX7 here, and we've got our tone stack. So what we're going to do is we're going to look at the wiring diagram for this amp, and we're going to check all of our connections on the chassis and make sure that they're good. So let me pop that up and we'll take a look at it. Okay, so we're looking at the wiring diagram here, and this is the signal path coming in that I showed you. And you'll see it comes in right here, goes through a pair of 68K resistors. This is classic Fender. Comes down here to the 12AY7. And then it comes out here and it goes to the volume pot, like we said, and it also branches out to the two 12AX7s. This is the 12AX7 that I was tapping and appeared to be microphonic. Now let's trace where this goes. It looks like, let's see, one leg of it goes through a capacitor and goes to pin 2 of this 12AX7, and that actually feeds the tone stack. If we look at the middle control and the bass control, where do they go? Let's see. They actually come down here to the other 12AX7. So we think that the problem has to be right here. Okay? I don't think the issue is in the output section. I don't think it has anything to do with that. I think we need to check our components and check our wiring and see what we have here. So that's what we're going to do in the chassis, and we're going to take a look at it. So again, signal comes in here, comes across like this, and this is where we're going to focus, right in this area. So let's dive in the chassis and take a peek. So as you can see, this amp definitely requires a little bit more work. I did go through the entire schematic to check and see if there's anything miswired or anything that's got a cold solder joint, and it's good. So I'm going to do two things here. I'm going to enlist the help of excuse me, Terry Dayton from D-Lab and our good friend Brendan, and see if I can maybe get narrowed down a little bit more. Like I said, the issue is coming in here, and it's really in this preamp section, I think, is the problem. So I'm not really concerned about the output section. So it's going to be the tone stack and the preamp. So I'll come back in a future odds and sods video and show you what the issue is. So let's move on to the next thing. All right. So the next thing that I'm gonna go over with you is a side project that I'm working on. Again, I got this from Terry over at D-Lab, and I thought it was a really good idea. So what Terry designed is basically a variac, but it works a little bit differently, and let me explain how it works. So basically what he's using is a Knight battery eliminator case, and I'll show you a picture of it. Let's take a look at it right here. Okay. So basically what we're doing is we're going to put a variac in the center, an AC variac, because the battery eliminator is all DC, so you have to rip that out. And we're going to put in an AC variac. We're going to have a voltmeter and an amp meter, and we're going to have a switch that lets you go between line and variac. And the reason why I think that's really cool is as you're testing a piece of equipment and you're on the variac, and you want to, if you feel confident that you can go over to the line voltage, it's a quick way to check and check your voltages, right? Because you're always going to get a little bit of a different voltage reading between line and variac. So with the flick of a switch, you're basically switching between line and variac. Now you'll see in the diagram here, there's no isolation transformer. I know someone is going to point that out. This will be connected through an isolation transformer, so I won't have to worry about that. Now basically the most expensive part of this project is two things. One is the case, that the battery eliminator basically, and the other one is the AC variac. And that was something that I've been searching for a while, and I lucked out big time. And I came across this Staco Energy Type 291 AC variac, and it covers 0 to 120 volts at 50 or 60 hertz, or 0 to 132 at 60 hertz. This one I'm going to use obviously is 0 to 120, and it's got terminals here, and you basically just put the connector on there and you're good. It's all gold plated. All right, this is all gold plated here, and it works really, really well. And here's why I lucked out. So I did a search on DigiKey and a bunch of other places, and this exact isolation variac was like $300. I was like, no way, right? So so I came across one on eBay, and it was $30. So obviously whoever was selling it didn't know what it was. I did test it. It works. It's not blown. It's not broken. It works fine. So I really, really lucked out on this one. And it'll mount inside the case, and it'll serve our purpose for our variac. So that's what we're going to do there. And then I'll show you a picture of Terry's. So let me show you a picture of what Terry's looks like. It's going to be right here. So I'm going to do the same thing, right? So I'm going to have you know, a plug in the front that you plug your basically, let me draw it for you and show you. Basically the same thing Terry did, right? So you're going to have your voltmeter, you're going to have your amp meter, you're going to have your variac, which is rated at 3 amps. The Staco 291 that I just showed you is. Here you're going to have a plug, all right? And here you'll have a fuse, and you will have a switch somewhere around here, I think, that goes between line and variac, okay? And this will have a plug coming out, obviously, and it's very simple. So you plug this into your isolation transformer. Whatever you're working on gets plugged into here. Set it to variac, works just like a variac. Switch it to line, it's directly on the wall. And we'll put a power indicator here as well, and make sure that we know that it's on when it's plugged in. So we're going to do that. That's going to be one of our future projects. Like I said, I was really lucky to get this AC variac, so really happy about that. So that'll be the next thing. So next thing I want to talk about, and the last thing for this video, is our radio that we got from Bill, old 64 Goat, and that was the Bendix Par 80. Honestly, with the holidays and all that stuff, I really haven't had the time to start recapping it. I haven't abandoned it, Bill, so it's coming. That's going to be on my list of things that I have to start working on as well. So I have to produce that first video. I just did a couple of caps on it. I didn't do much after that. So we're gonna produce a video on that as well, and we'll show you the progress of that radio and how that's going. And then for the rest of the year, I'm going to focus a little bit more on amplifiers and things, but I'm also going to try to focus a little bit more on some of the solid state things like Arduinos. I don't know if any of you have ever heard of an Arduino or know what it is. If you haven't, I'm going to try to do a little bit on that because it is the new way of developing electronics. There's a couple of kinds out there. There's an Arduino Mega, there's a Proton Particle. There's a whole bunch of them. These things are all Wi-Fi connected and LTE connected. You could basically build a circuit and control it from your cell phone 1,000 miles away, all on a breadboard. So I'm going to cover some of that stuff. You have to know a little bit of programming to do it, all right? Because there is some coding that's involved, and it's the C++ language, I think, is what they use. But we'll go through that. We'll build something together simple, and I'll show you how it works. So we're going to be doing that as well. And that's about all that's going on here. Again, I'm starting to build up my band calendar for the year. So my band, which is called Hittin' the Red, we already have, I think, 6 or 7 shows lined up, and working through the schedule for the rest of the year. And then the second band that I'm in, which is called Downpine, there's already a bunch of shows booked up as well. So what I'll do here at the end of this video, I'm just going to put a brief clip of New Year's Eve with the band Downpine of one of the songs that we were doing, so you can get a feel for what that looks like. And until that time, we'll see you in the next video, which will include an update on our amp, an update on our variac, and an update on our Bendix radio. All right, I wish you all well. I hope your New Year's going good so far. It's getting a little late to keep saying Happy New Year, so we won't do that anymore. But I hope everybody stays well, and we'll see you guys out there. And also, by the way, I noticed that I got a bunch of new subscribers. Thank you. For those of you that click the subscribe button, welcome. Hopefully the stuff that I post will be of some interest to you. And, if you have any questions, always put them in the comments. Thanks, folks. Take care. One other thing that I forgot that I wanted to cover here was this dummy load box that I used when I was testing the amp. This is something I built out of an old piece of test equipment that was broken. I think it was a frequency counter or something, whatever. It was a piece of junk from China. So I gutted it, and inside I put very, very large 8 ohm and 4 ohm resistors, like this big, like metal, right? And I don't want to take the screws out here. But essentially, I've got one for 4 ohms and one for 8 ohms, and I've got a BNC connector that comes out, goes right to the oscilloscope. So you connect this to the amplifier, and then you're able to monitor the signal coming out of here. It's a very simple circuit. And you know, those of you that know, you never turn any piece of equipment on without a speaker. It's supposed to be a speaker there. So this was really simple to build. I think the 2 resistors that I used in there, I got from, I think I got it from DigiKey, if I recall. And they were like, you know, 15 bucks or something. They were not expensive, and you know, they really served this purpose of building this thing. I also built another one a while back, and you may or may not remember that. If you want to see what one of the resistors look like, I'll show you. Because I also have a separate one here that I built. This is before I built this box. So here's the resistor, right? So here's an 8 ohm, 200 watt resistor. That's what's in here as well. And on this one, I just have a simple connector, and I have a wire that goes out, which you can connect to anything. So this is a kind of a portable one, but it doesn't have the oscilloscope output. All right. So if you're interested in building dummy loads, this would work. Piece of wood, isolated, right? Got some terminals there. All right, take a look at this video. I'll just put a few seconds of it up so you can see what I do on my other hobby, and I hope everybody stays well. Take care.